Okay, so something I forgot at the end of the last video again. We actually need to return something from this function. I didn't really forget, but I should have added this in because my plan was to do it this video, but then I realised it's just one line, so yeah, I should have added it in the last one. But anyway, we're going to return the len, so the length of lines to keep. Now, that's going to be 1 too big, so what we're going to do is -1 from it, because obviously our lines to keep, we're keeping like this line, this line, this line, so on, whereas we just want to know how many columns there is, so yeah, take away 1 from that. If we quickly just copy this and then print it, do this. Oops, what have I done wrong here? Put this -1 outside of this bracket. Something like that should work. There we go. So now it's telling us there's 5 columns, and if we go on to a different size board, it should tell us now there's 6. There we go. So, next step. I'm going to delete this, just we can bring it back. I've got another script, I can copy that in if we need it again at some point. So, I can also get rid of this. Oh, whoops, what have I done there? Okay, so next what we're going to do once we've returned the size of the board, we're going to want to be able to return pixel locations of like the center of every square into an array. So basically what we're going to do, we're going to my plan is we're going to have some sort of array, so like some numpy dot array. This array will be, say, 5 long, and then it would be 5 down. So obviously I'm not going to type all this out, but you can imagine. And this would have like the colours in and the blank squares in and stuff. So this would be red, this would be green, this one would be yellow. Like, hopefully you can see where I'm going with this. And then what I'm planning on doing is having another identical array, but just with the X and Y coordinates in, like in pixels of every square. So when it comes to drawing it, we can use the pixel values, and when it comes to solving it, we can use the colours and like the stuff like that. Hopefully, that's the plan. So we need to detect where the circles are. So for that, we're going to run. How are we going to do this? So where's this at? Okay, so we'll return it as center of circles. Since we want to return the pixel values, we'll return the center of circles. That's going to be equal to. Is that all we're going to want to return? Actually, something we can do. Something we are going to need at some point is we're going to need the pixel value of the size of a square. Now I could hard code this in, but since I want it to work for most size boards, or at least be able to be scaled to most size boards with a couple of tweaks, I'll show you the tweaks in a bit that we're going to need to make. I want it to dynamically create how big these squares are. So as far as I'm aware, a board is 430 pixels across. So what we're going to do is the size of square equals 430 divided by, and then we want the size of the board. So if we print size of square, we should get, so 430 divided by 5, that's going to be around 85-ish. So So well, it should be 86, I think. So we should get roughly 86 for this. I'll just comment that out since it's not finished yet. Yeah, 86. So that's working as expected. Obviously we would expect it to be smaller now. Yeah, there we go. So center of circles equals locate colors. That's going to be the function. Now locate colors is going to take in what we're going to need. We're going to probably need the size of the board, and we're going to probably need the size of the square as well. We're also going to need the original board image. Is that it? Pretty sure that is going to be it. So if we take in size of board, size of square, and then original board. Now create this new function, called it locate colors. Size of board we'll keep named the same. Size of square we'll keep named the same. And then we'll call this image. So first of all, what I've done in my my other script I've done before, this part of the code I'm not entirely happy with. If anyone knows how HoughCircles works, I'd love you to tell me. But HoughCircles I found to be really fiddly, and it was extremely difficult to get numbers to work on even just the 5x5s regularly. So to get it to work on like the 6x6s and the 7x7, I just couldn't do it. I couldn't get it to work for every single one at the same time. So what I think I'm going to have to do is just for now we'll settle with it just working for the 5x5s, and then in future I might have to change something where like it detects the size of the board and then runs like a different set of code depending on the size of the board or something. I'm not too sure, but for now this is what we're going to do. So these are parameters for our HoughCircles. This is some function we're going to run soon. I'll show you this soon. So I'm hoping that sorry, if we make this 30. Actually, no, I don't want to mess with these. These were fine and were working, so I want to try and keep them because, trust me, this is fiddly. I've messed around with this for a long time to try and get it working. I couldn't figure out good numbers. So we're going to use these for our parameters. Now we need to find the edges again, so we're going to use Canny edge detection. I'm going to call it the same edge of image again. In fact, I'm just going to paste the line in from the code because I'm pretty sure this is the exact same as what I've already got here. So image threshold 1, threshold 2. Obviously, if you've looked these up, you'll know what these are. Looking up the computer file video I referenced in one of the other tutorials. Whoops. Okay, so next, after we've got the edge image, we're going to blur it. This will help like smooth the circles out and make the HoughCircles detect them a little bit easier. So blurred image, this is using a Gaussian blur. If you don't know how this works, again, look it up. But basically what you do, you take a kernel, so we're taking a 5x5 kernel, which is basically just a matrix or an array. And it checks every pixel. So you take odd numbers here so that you can get it in the center. So say you got 5 pixels, like you'll pick the center one, and then 5x5, that 5x5 square is what your kernel will fit over, and basically you do different mathematic like transformations on all the numbers, end up with a single value, and that single value replaces the pixel that you were working on, and then when you've done that for all of them, basically it blurs it. So a lot of them just like average the pixels around. I can't remember exactly what Gaussian blur does, but I'm pretty sure it does some sort of averaging of the pixels around. Except it does it, I think, in like a weighted way, like it's weighted. So the closer they are, like I think basically the matrix, if I type it out, will look something like so it's 5 by 5, so it's going to be like 0 1 0 1 2 1 0, and then like you go under, it would be 0 1, say 3 1 0, then maybe 1 2 4 2 1. So hopefully you can see here, so this 4 would be a center pixel, so that would get the biggest value. So like you times its value by 4 before you do the whole average. So you're not gonna take this corner into account at all. This one a little bit, because obviously the further away they are, the less you're gonna want to have them influence how your original pixel comes out. Anyway, I'm going to move on from this. This shouldn't have taken this long. I probably shouldn't have went into explaining this, but hopefully you see how. And obviously there'd be 2 more rows on the bottom that would just mirror these 2 on the top. And you'd end up with a nice symmetrical sort of kernel that you're going to multiply by. So we're doing it with the 5 by 5 kernel on edge of image. I can't remember what this 0 is, but yeah, if you look this up, you'll find out. I can't actually remember. So once we've done blurred image, this is the function now that I have no idea how it works. It just does, and if anyone can enlighten me, please do. So this is HoughCircles. Obviously it does a very similar thing to HoughLines, but just detects circles instead. We're going to do it on blurred image. We're going to use this method. So this is the only method as far as I'm aware that there is at the moment, but it's there because it's able to be expanded on. Now all these, I've read what they do, but after messing with the numbers, I'm not totally confident that what I read was right. So I'm not going to tell you what they do. Feel free to look it up and find that out on your own. But basically, if you want to copy them numbers in, obviously min radius, max radius and min dist all come from up here. If you want to just copy them numbers in, feel free. They work for a 5 by 5, so I'm going to show you right now. I will try and draw them. So again, we're going to use a black image. Black image, number 0 is like image. We've seen this before. And then circles equals numpy.round. So what this does here is it just changes the type of data all to ints. Then for x, y and r in circles, because what you'll see if we print circles and I save that, whoops, yeah, one moment. Okay, so quick update on why it failed. When I previously was making this program, I actually captured the entire screen of floor 3, so the image was slightly bigger. So these numbers here, how I said they were really fiddly, yeah, these numbers were specific to that size window, so I'm now going to have to change them to try and get them working with our new square window. I'm going to do this off video because it's probably going to take me quite a while. But yeah, just bear in mind when I come back, some of these numbers will change. For example, I've changed these 430s, I've changed this 17 to 15. This is still not working, but you'll see it's detecting some circles, so you can see there, detecting like 5 of them. So yeah, I'm going to try and fix this and then I'll be back. Okay, so I'm back. If this is probably the best I'm going to get, so if you've still got the old numbers, copy these down. Main things I've changed: times 0.3, 0.5 and 0.1. Then I've changed this to 14.5, and parameter 2 I've dropped to 400. I don't think there's much else I've changed, just that. And I've added like a imshow the blurred image, imshow the circle image once it's drawn. and this is obviously drawing the circles. So hopefully, if you look at this output here, what it outputs, you can see it outputs three numbers per circle. Each circle is like a line. So this third one is the radius of the circle. You can see they're all roughly the same. You'll see why they're off in a minute. It's not actually a perfect detection, but it should work. Then we've got x and y coordinates. So we've got x position, y position, radius. So that's why in our code, as you'll see, we have 4 x, y, r in circles. So x position, y position, radius. CV2.circle, this draws a circle. When you pass it an image to draw on, you pass it an xy coordinate, like position wise, to place the center of the circle, and you pass it a radius. You then pass it a color, so we've gone for green. You then pass it a width, so we've gone for 4. So they're going to be 4 pixels wide, the edge of the circles. Then we're going to draw CV2.rectangle, so this will do a rectangle on the image, x and y positions of the top left corner, x and y positions of the bottom right corner, and then these are going to be fully white. -1, can't actually remember what this is for. Is this the size? Guess we'll see. Can't remember why I put a -1 here, but we'll see. So if I run this, you'll see we've got our circle image. They're all slightly off. Well, most of them are slightly off. Obviously, this red one up here is quite perfect. It's a shame that they are slightly off, but it should work fine because the thing I'm looking for is this white square in the middle. We want that to be over the color. So basically, what we're going to do, we're going to run a piece of code that will scan like the center of all these circles and say what colors there, and then that will be obviously helping us fill in the matrix. So the fact that the squares are over the color should be fine. I would prefer it if the circles are actually on the circles and not like coming over the edges, but yeah, HoughCircles, I can't get it to work properly, so if anyone has any suggestions again on that, feel free to let me know. So we can get rid of all these shows now. We actually don't need to draw the circles anymore either. This was just to show basically what it does, so we're going to get rid of that. Now if we print circles then and print circles afterwards, you'll see what that little line of code does. So you can see there it changes it all to int, because up here we've got like, oops, sorry, it is off screen. So you can see up here that where we first printed it, we've got like decimals, well, floats basically. These are floats. Then we convert it all to int, and you can see this is way easier. These actually give us pixel values. Obviously they're rounded, but they should be fine. So yeah, we're going to go ahead and keep the conversion to int in. Now let's get rid of that line, rid of that line. We don't need this black image anymore. Okay, so we've got the center of our circles, we've got the radius of our circles. Now we can just return the center of our circles, to be honest. There's not much else we need to do here. Is that all we need from here? Yeah, let's go ahead and do that. Then we'll have another function to generate the board. That will be next video. So, return circles. And then up here we'll see in main, center of circles. We should probably rename this. This isn't only the center, this is now circles. Or should we make it the center? Should we quickly do that? Yeah, let's quickly do that. So, center of circles. And now we need to change circles equals circles. We want the 0th element. Sorry, we want, okay, so center of circles is going to be a list, and then we're going to say for I in circles center of circles dot append, and we're going to append I 0 to 1, I think will work. And obviously this needs to be of circles, I think. Maybe, we'll see. This could be wrong. Print center of circles. I have too many brackets here. Yeah, there we go. Okay, back in a minute. Okay, so this is the piece of code we need here. So for I in circles, we need to print I from 0 to 2. That does the following, so it'll print the first two rows, the first two columns of our circles thing. So now what we want to do, we want to append those two rows to our new list. So instead of printing these, we're going to center of circles dot append. Now hopefully this works. There we go. So now we've got an array. You can't see it all, but basically we've got an array. We've got a list, of arrays for all of these. Now we're going to convert each of these to a list. Hopefully this works. I'm not too sure if this will. Yep, it does. So there we go. We've got a list of lists of the center of the circles. Now we're going to return this instead of this. There we go. So now we've got the center of the circles returned. We don't need to worry about the radius at all because, yeah, we just don't care about where the edge of the circle is. We just need to know where the center is so we can click on it. So yeah, that's going to be it for this video. This one was really long. Yeah, and in the next one we'll look at how to fill in two boards. So we're going to have a board with the colours in and a board with pixel values of the locations in, hopefully. That's possibly what we'll be doing next episode. So yeah, thanks for watching, hope you enjoyed it, and I will see you in the next one.